Hi everyone and welcome to this video about Pythagoras' theorem. So before we begin the content of this video, remember to please like and subscribe if you enjoyed this video and you want to see more content like it. And remember, you can always comment down below any questions you might have. And if you'd like me to make a video on another topic, please drop that in the comments section down below as well. Pythagoras' theorem is kind of scary sounding because it's got this word theorem in the name. And it's got this long Greek name, Pythagoras, as well. However, it's very, very simple to understand. It all stems down to a right-angled triangle. Now, a right angle is an angle that is 90 degrees, and we commonly label them, like in this diagram in the bottom left, with this square symbol. In order to use Pythagoras' theorem, we need to name the sides of our triangle. We only need to know the name of the longest side of the triangle so far. So in a right-angled triangle, the side that is directly opposite our right angle is known as the hypotenuse. And as long as we remember which side the hypotenuse is, we can always use Pythagoras' theorem. When we get a right-angled triangle, it's common to name the sides A, B, and C. Now remember that C is always going to be our hypotenuse. As for A and B, it doesn't actually matter which way round we name them. So in this case, I'm going to name the left side A and the bottom side B. Pythagoras' theorem links together these three sides of the right-angled triangle in this equation. A squared plus B squared equals C squared. Now remember that C is always the hypotenuse, so the square of the two smaller sides summed together is equal to the square of the hypotenuse. So this here is what is known as Pythagoras' theorem. One way to think about Pythagoras' theorem, if you're not too familiar with square numbers, is to simply draw a square with the side length of each of the three sides of the triangle. So I'm demonstrating that here. Let's say that this side of the triangle was length 3, this side of the triangle was length 4, and our hypotenuse, remember opposite our right angle, has length 5. Let's just do a quick calculation of the areas. This on the left has area 3 times 3, which is 9. On the bottom we have 4 times 4, which is 16. And up here we have 5 times 5, which is 25. Let's see if Pythagoras' theorem works for this triangle. So we said that we want the squares of the smaller sides to add up to the square of the hypotenuse. And checking that, 9 plus 16 does in fact add up to 25. Now remember, you will be expected to know Pythagoras' theorem off by heart. An easy way to remember it is that the square of the hypotenuse is always the subject of the equation, so it's by itself on one side of the equation, and hopefully using that, you should be able to remember where to place each of these numbers. Let's have a look at an example question together. This is a very simple question just to show you how to use Pythagoras' theorem. We begin by writing down the formula, which is a squared plus b squared equals c squared. I always suggest writing this down before we start doing any work. Now we're going to identify which sides of the triangle I have. Now I find the right angle first, and I look for the side opposite that, and I'm going to label that C, just so I know that it's the hypotenuse. Now I know that 1.35 is going to correspond to A, and 3.25 is going to correspond to B. Remember, it doesn't matter which way round you assign A and B, so I could have 3.25 as A and 1.35 as B. So let's write that down. Once we've written down the A squared and the B squared, it's very easy to forget what this is equal to is not in fact the length of the hypotenuse, but the length of the hypotenuse squared. So always write C squared on this right-hand side. Never write C by itself. And don't be fooled into working everything out in the calculator thinking that will be your answer straight away. What we can do next is to square root both sides of the equation. And now the left-hand side is in fact something that I can put into my calculator because the equation has C as the subject, not C squared. And if we work this out, we find that it's 3.52 meters. Let's take a look at a second example together. Again, I'm going to write down Pythagoras' theorem before I begin. Then I'm going to go to my diagram, find my right angle, find the side opposite it, and label it C. Now I can label the other sides A and B if I wanted to. And I can see here in this case, I don't have C as my unknown side, or my hypotenuse as my unknown side. I'm looking for the side B. That's okay, I'm just going to go into my equation and replace the variables that I have. So instead of a, I'm going to write 17, b can remain as is for now, and then I'm going to write 25 instead of c. The next step is to rearrange this equation. If you're struggling with this step, let me know in the comment section down below, and I can do a video on rearranging of equations if need be. But what I'm going to do to both sides is subtract 17 squared, and that's going to leave me with this expression here. And the next step is to square root both sides, and this is something that I can put into my calculator to work out. And this comes to 18.3 centimeters. Now a check that you can do once you've found the numerical answer for these questions is to go into the triangle and just compare the lengths of the three sides. We can see that the hypotenuse is always going to be the longest side of the triangle. So if we worked b out to be larger than 25, we'd know we'd got the answer incorrect. However, this case 18 is indeed smaller than 25, so as a rough estimate, we know we're on the right path. Let's take a look at one final example together. This is going to be a multi-step question, so we're going to take it one step at a time. Of course, beginning with writing down my Pythagoras' theorem, making sure that I know that this question is in fact going to need it. Okay, and the way to do that is to see if you're looking for sides of right-angled triangles. If you have two sides and you're looking for a third side, you're always going to need Pythagoras' theorem. So this top triangle is connected to the bottom triangle by the side BD, and if I had BD in the bottom triangle, I would be able to use Pythagoras' theorem to work out the missing side x. If we pay attention to the bottom triangle, we see that x is the hypotenuse of the triangle BDC. So my first step is to work out BD, and my focus is going to be on the top triangle. I'm going to label the sides in that triangle first, finding my right angle, labeling the side opposite that to be C, and then the remaining sides A and B. Let's replace our numbers in the formula, and let's rearrange and solve for B, subtracting 5 squared from both sides, and then square rooting both sides. I'm going to leave this answer in exact form for now, because I know I'm going to use it when calculating x in the bottom triangle. I always suggest not working out a numerical answer halfway through a question using exact a form as possible before in the final step converting into a decimal. Now we've worked out BD, it's time to look at the bottom triangle, so I'm going to relabel everything. Starting with my right angle, I find the opposite side and label it C. The other two sides can be A and B. We can see that C is the side that's missing because we've worked out A in this case. So let's replace that in my formula. It's going to be 5 root 3 squared plus 4 squared equals C squared. Remember, it's C squared, not C. I can square root both sides of this equation now, and I work out C to be the square root of 91. And if I wanted that as a decimal, that would be 9.54 to 2 decimal places. Thank you for watching this video. I'm glad you've made it all the way to the end. If you have any questions about the video, remember you can leave them down in the comment section below. Please like and subscribe if you enjoyed it, and I will see you in the next video.